of electromagnetic wave. So we already discussed several topics in the electromagnetic. What is the topic we discussed? No, related to this electromagnetic induction. So electromagnetic induction, electromagnetism, and electromagnetic wave. So that means the wave that comes from the electromagnetic. So when the wave comes from the electromagnetic, it's a source of the things. That means this electromagnetic wave means what do you mean by electromagnetic wave? What do you think that electromagnetic wave? You understood my question. What do you think that? What do you think? What do you mean by electromagnetic wave? No, that's a mistake you did. That's why I asked you this question. Electromagnetic wave source is electromagnetic. It's coming from electromagnetic. So anything you can take, you can source that. You need not be it need not be electromagnetic line. For example, electromagnetic will produce several waves. So several waves, electric and magnetic field is nowhere connected to it. In this series, for example, we got for the visible spectrum. Visible spectrum, what is example for a visible spectrum? What is example for visible spectrum? Which wave? Visible. Which is what is example for visible spectrum? Huh? What is example for visible spectrum? You understand? Visible spectrum. Yeah, sun. You are seeing sun, right? You are seeing sun. Morning you are seeing, night time, morning, afternoon, evening. All the 3 times you are seeing the sun. Then night times you are seeing moon. So this is all are example for the visible spectrum. That visible light is there, so you are seeing. If it become higher, you can't see sun. You can't see the light that is emitting is in the visible region. What is the visible region? 400 to or approximately 500 nanometer. Approximately 500 nanometer. Approximately 500 nanometer comes means it's a visible region. For example, if the sunlight is around 100 nanometer or 1000 nanometer, can you see the sun? No. Yeah, you can't see the sun. So the sun you are seeing, moon you are seeing, everything will fall under visible spectrum, which is around 500 nanometer. But if for example same light comes under 100 nanometer or 1000 nanometer, what will happen? You can't see it. So there comes so electromagnetic wave is the one that produces the wave that in the various spectrum, infrared, visible region, ultraviolet, X-ray, gamma, all the waves are coming in. But it need not have a electromagnetic character. So electromagnetic is produced from the electromagnetic wave is produced from the electromagnetic source. So electromagnetic source producing for the electromagnetic wave, so that wave does not have the character of that wave that does not have the character of that wave does not have the electromagnetic wave. For example, if you go for light or visible light, it does not have the perpendicular current passing. It has two nature. That view, that only that we have what the two nature we have seen in the theory of relativity. Two nature. What is the two nature of the light? Dual nature of the radiation. What do you mean by dual nature of radiation? Which radiation? We will go for light itself. Wave nature, then particle nature, not photonic. Photonic is a particle. It's called mass. Its mass called photons, but particle nature. Generally a particle. See, if I take a thing, if I take this, I am taking this 2 chair. Okay, both are chair. Okay, but which will be high weight? Which will be heavier? That chair is heavier. This one will be light, but both are chair. But with respect to mass, it will have the mass will vary. So something it will vary. What are you saying? That's not our problem. My problem is what is 2? What is 2? 2 are chairs. So like that, there is a photonic is a type of mass. But what is that? What it has? It has a mass-like character, then wave-like character. Both are characters. That's why it's called dual nature of the radiation. Something. So electromagnetic wave comes means that does not mean that it has a electromagnetic character. The source is electromagnetic. The source is electromagnetic. Source is electromagnetic from the electromagnetic. So the source is different from the character. if the character is the source is different from the its source is electromagnetic from the electromagnetic source, the character will be different. For example, light has two nature, dual nature of the radiation, which is wave like nature and mass like nature. Its mass is called photons. So, displacement current, okay. Displacement current, what I gave you, displacement current, first one.
The current due to charge is electric field.
Total current is equal to IC plus ID, IC is equal, IC plus ID, I is conduction current, ID is displacement current, so is equal to IC plus E0 d phi by dt. So this is the total current that passes for any charge of induction. Any charge. If you pass the charge, if you pass the charge, total current, the total current that is passes is equal to conduction current. Then what is meant by displacement? Difference between displacement current and conduction current? Do you understand my question? Both are current.
When the carrying conduction current வந்து carry பண்ணும் current.
Okay, displacement current?
Electric field வந்து change பண்ணும்.
Displacement current. What is conduction current?
Current carried by a conductor due to flow of charge.
Flow of charge. What is displacement current?
The current due to change in electric field.
The current that comes due to change in the electric field. That current and this current both are current, but difference is that this is due to conduction current. This one is due to magnetic field. The current that arises due to magnetic field. Then this value I give integration of B dot dl equal to nu 0 IC plus nu 0 E0 d phi by, this is same thing. So this one nothing but only ampere Maxwell law. Now we go for source is there, no? Source of electromagnetic radiation. Nature. What is the source I give?
Take any charge with a definite frequency in an electric field E,
Yeah.
so that produces a magnetic field.
Magnetic field. Okay. Then nature. No, it's the source now varies for. What is the source for visible light? Okay. What is source for? For example, you are seeing the sun. Okay. Sun. Why you are seeing it? Because it produces the light. What is the spectrum of light? What is the wavelength? Light. 500, approximately 500 nanometer. So if the light produces the 500 nanometer means you can able to see. That does not mean that it only produces the light visible spectrum. It produces infrared and visible ultraviolet both. Okay. So it produces both. Only thing, ozone is there. What is the ozone? Purpose of ozone? Protect the ozone is there. What is ozone structure? O3. O3 that will protect the very harmful ultraviolet rays. Otherwise, our life will be affected. If there is no ozone, what will happen? Ultraviolet enters the earth. It will spoil. In what way it will spoil the ultraviolet? Even UV. No. How UV will damage the life on the earth? No, it will not die. What damage it will cause?
Skin problems varum, eye damage varum.
It will induce the, no, if the ozone is not there, whether it's animals or human, it will induce the cancer. It induce, this is called cancer. So that's why God created a called ozone layer called ozone layer in our earth field, earth surface. If there is no ozone, what will happen? The earth, some the sunlight along with visible light, UV light also will come, ultraviolet light. So that ultraviolet ultraviolet rays. So that rays will pass to the entire human, human and animals. Both will get the cancer. Both are the both are the cancer that will induce the cancer. So that's why ultraviolet. So it's not sun only. So it's not only sun producing the visible region spectrum. It produces also ultraviolet region. So but we need only the source to produce only light. So we have to pinpoint something which is produce visible, which is infrared, gamma, then X-ray. We need only one source with the corresponding one spectrum. We don't want to produce everything. The nature of that we will see now. That we will see after this nature. What is the nature thing? Ex is equal to E0 sin kz minus omega t, and by is equal to b0 sin kx minus omega t. So both now what is it? Now what it tells that magnetic field and electric field and magnetic field are perpendicular. If perpendicular means if the electric field lies in the x-axis, magnetic field will lie in the y-axis. Then which equation I gave? Nu is equal to root of 1 by root of what equation I give? Mu 0 B0 is equal to E0 by C. What equation I gave?
2 pi mu equal to C root of 2 pi by x lambda.
Yeah. No. Repeat me. Nu is equal to
2 pi mu is equal to
2 pi nu is equal to C
into root of 2 pi by lambda.
Root of 2 pi by lambda. Okay. 2 pi nu is equal to C into root of 2 pi lambda. Okay, so nu is frequency, C is constant, lambda is wavelength. So nu is inversely proportional to
Frequency and wave.
Nu is okay. Frequency nu is inversely proportional to wavelength. Why are you blinking for everything? You are blinking. Nu is inversely proportional to lambda. That is 2 pi root of 2 pi C is what? Constant, not constant or speed of light. It's a constant value, 3.3 into 10 power 8 meter per second. So it's taken as constant because it's a constant value, speed of light. Now we go for the various spectrum. The spectrum says that it has radio wave. You have that?
Yes, sir.
Radio wave, microwave, infrared wave, visible range, ultraviolet, X-ray, gamma. So the frequency radio is approximately 0.1 meter. Okay. Then microwave is 0.1 meter to 1 millimeter.
1 meter to 700 nanometer.
700 nanometer. Light is 700 nanometer to nanometer. Ultraviolet is 400 nanometer to 1 nanometer. X-ray is 1 nanometer to 10 power nanometer. So this if it is there, where the source of this X-rays. So where are the source of the X-rays? First one is where is the source and where it is applicable. Where you apply for X-rays? Where you applicable for X-rays? X-ray.
In a hospital.
In hospital what? For what purpose? For what purpose?
They take X-rays bone.
X-ray of the fractured bone. If the bone is fractured means if you take X-ray, you will get the very good idea where exactly the bone, so that they will make heat treatment according to that. Because we would like to know exactly where the position is and how the position is. For sometimes exactly position where got breakage. Then how depth the breakage is there. Everything can be pinpointed from the X-ray. So this one X-ray. Then how arises? The X-ray will arises from the inner shell of the electron. Inner shell means
Innermost.
innermost. Yeah, inner shell. That's the innermost. Innermost.
Ultraviolet வந்து inner shell சொன்னீங்க. X-ray வந்து innermost சொன்னீங்க.
No, both are innermost. That's a low element.
Most இது light element.
It's light element. Ultraviolet is from light element. This one is just very high element. Heavy element. What is heavy element?
Uranium.
Uranium. Polonium. Uranium, polonium. From there, innermost shell electron transfer. But if you go for a UV, light element. That then what is the application of UV now? UV, you have to see the source and the application. Source is innermost electron of the light element. So application is photographic film. Photographic film. Photographic film. That one you taken for X-ray. What is X-ray you taken? No. For the fracture bone. So gamma rays also say X-ray and gamma rays are almost same. That also we will be used in the for the development of the film. So gamma rays and source is radioactive material. Any radioactive material like any radioactive material if you keep it will evolve alpha, beta, gamma. So the gamma rays now it is utilized in the for industrial application like taking images, scan images. Then how will you get from alpha and beta? How will you separate the gamma? You understand my question now? Alpha, beta, gamma. If you take any uranium material, any nuclear material and keep it, what it will emit? Alpha, beta, gamma. Alpha is positive, beta is negative, gamma is neutral. So how from that how they will separate only gamma? Because we don't want alpha and beta. What industrial application is only gamma. So how they will get only the things? How will they get only gamma?
Alpha and beta attract.
No. They will keep that plate with hole. This one is with positive and negative charge. Okay. They will keep one plate with a hole, positive and negative charge. What is alpha? Alpha is positive charge. Will be absorbed by the negative charge. Negative charge of the particle. Then beta is negative charge. Will be absorbed by the positive charge of the particle. Now only left is gamma. So only gamma will come out now. Because they need for industrial application like scan. For that they don't want alpha and beta. But nuclear material will evolve both. All the three it will evolve. Alpha, beta, gamma. So they will get only this. So you write this. Did you write these words?
Yes.
Just write these words. Okay. You finished? Okay. So
Microwave application என்ன சார்? Infrared.
microwave, radio wave, infrared. Infrared is vibration of atoms. Infrared is vibration of atoms.
Okay sir.
Then application is that also an application. Did you see that camera that will take in the night? Did you ever visit any forest like Satyamangalam? No, not green color. It could be anything. They will for watching that momentum, watching the movement of the animals. What they will keep in the forest, they kept one camera that will shoots only in the night. That means whatever the animals comes in the night, it can be visible in the night time. Night time, the morning you don't have problem. Morning you can keep ordinary camera. So like this you can keep ordinary camera. In the night time, especially the camera is there. So that is infrared thing. So because it will pinpoint the momentum of animals, especially momentum, any momentum of momentum of organism. If man, animals, everything is moving in the night time, that will be photographed. So that they will when once it's recorded, they will take it when it's needed. It is not 1 day or 2 days. Every day they will make the So every day they will make the record, but whenever it needed, they will take only in the night time. That is 6 a.m. to 6 p.m. to early morning
6 a.m.
a.m. It will be they'll make that program, especially in the forest. What is the forest? You know, well-known forest. Forest. Amazon. No, Amazon is not governed by it's private. Nobody, tribes will be living. Here in Tamil Nadu, Satyamangalam. It's near, I think, Ooty, I think, near Satyamangalam forest. Because they want to take the momentum of all animals and organism. That is, man also can come and hunt the animals. So for that, they have specially this thing. If any animals is missed, means what will happen? Some animals is missed. For example, today's lion is missed. Okay, what they will do now? They search in the camera because the lion is missed here. Somebody has entered the forest and hunted it. So it should be the various path is there. All the path they might have kept in the night. Morning time, no problem. Because morning will be lot of forest. The night time. So they used only for that. So then it's infrared, then vibration of atom and molecules. From the vibration of atoms and molecules, the infrared will evolve. Then microwave. Microwave is a magnetron from a specially called magnetron. There is a material called magnetron. From there the microwave comes. So industrial application is microwave oven, right? Microwave oven that is generated from the magnetron. Then radio wave you know very well. That is used for the radio communication, television, all the things, satellite communication, everything. Radio. So for that it is two types. The radio and radio is which ranges? Approximately 1000. What is the range of radio and television? 0 point? 0 point? 0 point. The wavelength is around that range. Okay? That's all. We all 7 spectrum wavelength we covered, no?
Yes.
Yeah, okay. That's all.